Alright, next question is question number 6. A block B of mass 2 kg is lying on a rough inclined plane sloping at an angle of 30 degrees to the horizontal. A light roof inclined at an angle of 20 degrees above the line of greatest slope that is attached to B. The tension in the roof is T Newton. There is a frictional force of F Newton acting on B. You can see in the diagram. The coefficient of friction between B and the plane is mu. It's given to you that F is equals to 5 and the acceleration of B up to the plane is 1.2 meters per second square. You have to find this T. Your first step should be understand the figure. You can see this figure is inclined, so your first step should be divide this figure into its component. So if I like to resolve this figure into its component, that gives me t cos of 20 degrees and also t sine of 20 degrees in the upward direction. You can say t sine of 20 degrees, right? Next is there is a factor of mass because it's given to you that it having a mass of 2 kgs. So convert 2 kgs into just like you can say gram, you can say. So it would be acting in downward direction. You can also convert it into gram if you want. If you don't want, then write it as it is. So it would be 2 kgs. After that, resolve this mass into its components. That will be, because it's an inclined of angle 20 degree, this thing, so that is resolved over here, right? Next is mass that is having an angle of 30 degrees, so you can see it would be 2 sine of, or here you can say it's acting downward, so here it would be 2 cos of 30 degrees and here would be 2 sine of 30 degrees. All right, yeah, it's fine now. So you can proceed now. Use the one of the famous law of you can say Newton's second law of motion, that was F is equals to ma, because a lot of forces are acting over this body, resistive force, forward force, and all these things. So you can see that summation of F is equals to ma. So forward force for that case will be t cos of 20 degrees minus 20 in the in the backward direction. This t cos of 20 degrees in the forward direction and this 20 is in the backward direction, sine of 30 degrees actually, minus mu of r, which is equals to 2 times 1.2. Why I just consider mu of r? Because it's given to you that there is a factor of frictional force. Frictional force came to an account, so that's why frictional will oppose the motion, so it will be with a negative sign, that would be minus mu r. Put the relevant values over here and do the simplification. That gives you t cos of 20 degrees minus 20 times 1 by 2, just sine of 30 gives you 1 by 2, minus mu times r is given to you over here, that is 5. Plug in its value, that gives you is equals to minus 2.4. After that, t cos of 20 degrees, which is equals to 17.4, and t would be 17.4 dividing by cos of 20 degrees, then your t would be 18.52 Newton. That is the answer for this tension, for this A part. 18.52 Newton is the answer. For the second one, find the value of this mu. You know that mu r is equals to 5. In the question it's given to you that. So mu can be calculated as 5 by r, and r value is basically what? Definitely you have to calculate its value first in order to plug this value in this equation. For example, this is equation number 1. How I can calculate the r? You know that r is a reactional force that is acting in upward direction. So it would be r plus t sine of 20 degrees, because r is the force that is acting in upward direction and upward component is treated as sine. So that's why it will be with a positive, it would be in the sum position with the sine of 20 degrees. That would equals to 20 cos of 30 degrees. If you go back to the figure, you can confirm this thing. Let me show you. Here is r. So this r is the sum of r plus t sine of 20 degrees, and it's opposite to the 20 cos of 30 degrees, means action and reaction are equal, so this and this factor will cancel each other. So you can say r plus t sine of 20 degrees will equals to 20 cos of 30 degrees. So use this figure to confirm your answer, confirm your steps. So that r would be 20 cos of 30 degrees minus, this is t, and t value is calculated in the a part, that was 18.52 sine of 20 degrees. Do the calculation. Your r will be coming as 10.986. Now you know the value of this r. So plug this relevant values in this equation number 1. That gives you mu is equals to 5 over 10.986, and that will further give you 0.455, or up to 3 decimal figures, 2 decimal figures, you can say it would be 0.46. That would be your mu. Final answer for this question.